Good evening everyone, welcome to this session of Graphical Method 3. We have been talking about linear part programming and we have been talking about types of solutions and we have had discussions. So continuing with the discussion, let's start this thing. I hope you are really great out there, you're doing awesome out there, okay? Okay, fine. So this is me, my name is Rahul Kanyal. I have had the opportunity to work in a BHEL, a PSU company for around 2.2 years. Then I quit it and went to IISc Bangalore to do my masters. Now I'm here in front of you. Let's get started. Now we have a live session for ESE 2020 on 5th of Jan, and if you want you can tune in, okay. And we also have a mega mock challenge. You can register it with us, okay? Yes, fine. So let's understand the concept of redundancy. YouTube live, hi, I'm really great, how are you? How can we stop laziness in studies? Okay, this is kind of off question from the topic that we are doing, but still I'll answer you. You need to do more physical work. If you want to do away, if you want to take away any laziness, you want to exercise, you want to get up in time, do yoga, meditation, walk, whatever works for you, go to gym. You know, if your body becomes vibrant, your mind also becomes vibrant, okay? So I think this is the way to avoid any laziness out there. Did you get your answer? YouTube live? Okay, fine. Thank you for that question. Now let's get started. Now let's understand the concept of redundancy. We have been talking about feasible regions. Let's say this is a feasible region. Okay? And what if I add one more constraint to it? That is a lesser than constraint, and that says go inside, downwards, okay? So if you observe again, the result of adding this constraint is the same feasible region, agreed? Right? X1 and X2. The feasible region does not change. This is what I want to tell you, right? So this constraint is called, this constraint is redundant, okay? Yeah, thank you very much for the comment, fourth wall, okay? You are really amazing. All right, so let's do better in life. Let's get to the heights of glory. Let's do our best. Okay, this is what we can do, right? And I've always believed that one must not give up. One must keep on working on himself so that he reaches the top of life. All right, this is why we are here. We are here to experience life in its fullest, right? Okay, fine. Fine. I hope you understood the concept of it. I'm going to repeat it again. If you add a constraint, that does not change the feasible region and hence the optimal solution, or we can say or even for that sake any other solution, okay? That constraint is called redundant constraint. Redundancy means that which is not required, okay? Fine. Now can you please do this question? Can you plot these inequalities and find out which constraint is redundant? Can you please try this? You will have to plot these, right? And if you don't know how to plot the inequalities, I have explained it in previous videos. You can go back and look at them, all right? How do we plot inequalities, okay? Okay. Okay, so can you please start plotting them? Firstly, 2x plus y less than equal to 1000, let's find 2 points over here, so that we plot, firstly we plot the line, right? So we are going to plot this line over here. Which line? We are going to plot this 2x plus y equals to 1000. Yes, so I just need 2 points to define a line, right? Okay, then if I put y equal to 0, x equal to 500, comma 0, if I put x equal to 0, y equal to 1000, alright, I'm going to join these 2 points, so I get this line. Yes, and this is a less than equal to type sign, and the coefficient of y is positive, so it says this area, the left area, the bottom area. Yes, this is what we have been discussing, right? Right, so you also please plot. Now let's plot this 3x plus 4y less than equal to 2400. For that we need to plot this line 3x plus 4y equals to 2400, right? Then the first point, when I put y equal to 0, I get x equal to 800, comma 0 over here, right? When I put x equal to 0, then I get a point here 0, comma 600, right? 600. So this is the second constraint. It also says go inside, right? Because the coefficient of y is positive and it's a less than equal to side, so it says go down, not up. Alright, this is what we have been talking about. Okay, now the third one is x plus y less than equal to 800. Similarly, we are going to plot the line. So the line is going to be like this. This was the first, this is the second, this is the third. Again it says go inside. Which one is the feasible region? This is the feasible region. Feasible region means the region that is common to all. Okay, so this is it. Now which constraint, if I remove it, will not change the feasible region? Can you answer it? Please look at it. Please look at it. Which constraint, if I remove it, will not change the feasible region? This is what I am asking you. Which one? Anyone? Third one. Okay, Mohammed says the third one, and he is right. If I remove this third one, right? If I just remove this third one, see me, that's gone. The feasible region is going to be the same. Good, good, Mohammed, you are right. The third one. So third is the answer. Which one of the above constraint is redundant? The third constraint is redundant, which means that is not required. That is what it means. Good. Good, Mohammed, it's good to see you again. Fine. Okay, is that clear? I think this is clear. Okay. Now sometimes questions are asked in GATE and IISc regarding dual of a problem. Okay, let me write an objective function equal to a x1 plus b x2 subjected to c x1 plus d x2 less than equal to e. Okay, then f x1 minus g x2 is greater than equal to h x1 comma x2 is greater than equal to 0. Alright, this problem is called primal, and we are going to write the dual of this. Alright, the dual of primal. So how do we write it? This is a standard format of even before that, let me tell you that if for maximization type problem, convert all constraints to less than equal to type, and similarly for minimization type, convert to greater than equal to type. This is the rule that one needs to follow. Alright, and this is very, very, very important, and you need to get hold of this. Okay, now this is a maximization type problem, right? And all the constraints should be of less than equal to type. This one is less than equal to type, and this one is greater than equal to type. We are not touching this, okay? You cannot touch this. This is how they remain, right? Because number of units, for example, cannot be negative. Last time we saw it, we had a discussion about it, why they are always greater than equal to 0. Yes? Okay. Now I need to convert this. Okay, so what I'm going to do, I'm going to convert it to less than equal to type. To do that, I'm going to multiply this inequality with minus sign. So this becomes minus, plus, this becomes minus, yes, and here it becomes less than equal to, right? Is that good? Okay, okay. Now dual of this problem is written something like this. Now you see the right hand side over here. Okay, and because it's a maximization type, you write minimize Ex minus Hy. Ex minus Hy, where x and y are other decision variables. You'll get to know this. Okay, subjected to, you take your constraint from here. Okay, that is Cx, C from here, then minus Fy. Okay, and this is less than equal to, so the sign changes here. It becomes greater than equal to A, the first variable over here, not the variable, the first constant over here. Alright, the first constraint is written like that. And the second, dx plus gy is greater than equal to b, and x comma y is greater than equal to 0. This is how dual is written. All right, you there? Hello everyone. You there everyone? Akash says, sir, ye hai kya? Actually, see, we have been talking about maximization or optimization of a function. This is industrial engineering. All right, this is linear programming, graphical methods. And we have talked about solving it, and we are actually writing a dual of primal. Let's say we have a problem like this. This is the mathematical expression of that problem, and this is called primal, okay? And we are trying to write dual for this. This is done to check the accuracy of the solution given by primal. That's why we are doing this, all right? Hey Vignesh, I hope you are doing really great out there, okay? Just follow it. Okay, fine. So, this is how it's done. This is how it's written, okay? These two are the conditions. For max type problem, you need to convert all the inequalities to less than equal to type and vice versa. This is what we did, right? Ex minus hy, and this is maximum type, so this has to be a minimization type subjected to Cx minus Fy. Now here we have less than equal to, here we will have greater than equal to A. Similarly for this, dx, look here, dx plus gy should be greater than equal to B comes from here, xy greater than equal to 0. I have repeated it. I think this is clear now. Okay, fine. Okay. Is that good? Okay. Now, if you remember, this question we have had done in the second session, I guess. Okay, and it was giving, this is actually primal, and this gives an unbound solution. Now, can you please write its dual? If you understood it correctly, can you please write down its dual? Can you please do it right now? Do it. If you are there, please do it. Are you there? Just say yes if you are there. Otherwise, I am going to continue. Okay, Ashish says yes. Okay, please Ashish, if you understood this, so please go ahead and write the dual of it. Okay. And these things are very important, and 2 marks question can be asked anywhere, ISRO, IISc or GATE. Anywhere you can get very easy 2 marks, so don't lose them. Alright. Yes. Okay. Yeah, so 2 yes I got, I'll take those. Okay. And okay, Vijay says unbounded. Again, Vignesh, okay, fine, good. Good. So can you please try? Firstly, write the dual of this problem and try to find the solution of that dual. Yes, so please do it. Please do it, Muhammad Yusuf, please. Now, it's a maximization type problem, so we need to convert everything to minimization type, yes? So this is already minimization type. I need to convert this to less than equal to type, not minimization type, sorry for that. So I'm going to multiply this by minus, so 12x1 minus 4x2 is less than equal to minus 36, yes? Minus 12x1 minus 4x2 is less than equal to minus 36, because when we multiply by minus, the sign of the inequality changes, right? We have discussed it. For example, 4 is less than 5, right? And if I multiply this, minus 4 becomes greater than minus 5. This is what we have been discussing all the time. I hope you understand this, yes? Okay, so first constraint is this, and second constraint is this one, 12x1 minus 6x2 less than equal to 24. So can we write dual for this? Okay, considering decision variable x and y. Just take 2 variables x and y, and let's try to write it. All right. Yes. Now, falling short of space, minus 12x1 minus 4x2 minus 12x1 minus 4x2 is less than equal to minus 36, and 12x1 minus 6x2 less than equal to 24. 12x1 minus 6x2 less than equal to 24. I hope this is correct. 12x1 minus 6x2 less than equal to 24. Yes, minus 12x1 minus 4x2 less than equal to minus 36. Okay, let's try to plot them. not plot them. Let's try to write a dual for them. x1, x2 is greater than or equal to 0 in variables x and y. So what do we write? Because here, okay, maximize z, 15x1 plus maximize z equals to 15x1 plus 20x2, 20x2, okay, and these are the constraints. So what do we write? This is primal. We are going to write dual as, what do I write? Minimize, because this is a maximized type problem, so minimize. I'm going to take the coefficients from here, yes, minus 36x plus 24y subjected to, I'm going to take the coefficients from here as well, yes, so minus 12 into x plus 12 into y, because this is less than equal to type, so I'm going to put here greater than equal to type. Right, 15 comes from here, right. Similarly, see this minus 4, minus 4x minus 6y greater than equal to 20 from here. X comma y greater than equal to 0. This is the dual of the problem. I hope this is very clear to you. This is very straightforward, okay? Yes? Right? Now let's try to plot it. Okay, Vignesh had already given option B. Okay, fine. Let's try to plot this. Okay, free. This is x, this is y. (1.25). So here it is minus 1.25. Okay, and y is positive 1.25. I plot this line, the line given by the equality sign. Okay, this we have been talking about a lot. We have done a lot of this there. Okay, now this says greater than equal to, because the coefficient of y is positive, so it says this side. Okay, now let's plot this. X equals to minus 5 comma 0, right, and y is still negative 20. That is minus 3.33. So I'm going to join this, alright, and I'm going to actually overwrite this. No, overwriting won't be a very good solution. I'm going to delete this. So let me change the color. Okay, this is the first line, this is second line, and the coefficient is negative. So again, for plotting the region of it, it's greater than equal to type. So when we make it positive, it will become less than equal to type. So this is the region that it's talking about. Alright, so what's the common region over here? Common region is this one. Alright. Hi Kirti, everyone. Okay, are you following this? Yes? Are you following this? Yes or no? Are you getting this region over here? YouTube live. Mishra ji, bilkul. Yes, yes, you got it right. Mishra ji, welcome here. Okay, fine. Yes. Okay. So what is the type of solution do you think it is? What is the type of solution it is? Unbound, are you sure? Are you sure? Unbound? Mullah say, Muhammad Yusuf says unbound. Okay. See, Devansh, there's no fixed relationship between primal and dual. Anyone else? Anyone else who says this is unbound? What about this constraint? This is also there, right? X, y greater than or equal to 0. Are you getting this region? But what about this? X, y greater than or equal to 0. Everyone should, the feasible region or the region that we are talking about, it should be in the first quadrant. Right? It says B here and it says B here. Right? So what kind of solution is this? So what do you see it is? Devansh, what is the type of solution you are getting here? And let's not generalize it, okay? Let's not generalize it over here. Is it infeasible? Muhammad Yusuf says it's infeasible. Devan says unbounded. Vignesh says unbounded. But what about this constraint? X, y greater than or equal to 0. This says that it should be, everything should be in the first quadrant, right? So that's why I'm saying, Devansh, let's not generalize it, okay? Vignesh says infeasible, okay. Because this cannot happen because of these. X, y greater than or equal to 0, so the solution is infeasible, okay? Alright. Is that good? Yes, Ranu, this session will be only in English. I am compelled. I can speak Hindi and English, but yes, this will be only in English. So sorry for that, okay? So Mahesh also said infeasible. Okay, fine. Good. Did you all get this? Did you all get this region? Mahesh, Mohammed, Vignesh, Devansh, the people? Did you get this? Okay, fine. Okay, good then. All right, okay. Okay, let's move ahead. Okay, can you find this and let me tell you, Let's say this is primal. Okay, and we have already seen that this gives infinite many solutions. So can you please try this, writing dual of this and then trying to find the solution of this. Can you please do it? Please plot it and tell me the answer of this, every one of you, those who are online right now, those who are watching it. And I believe that you are here because you want to do something, right? You're not just chilling out there, immersing in New Year celebrations and parties, because you believe that yes, time must be utilized, because time is important. This is what I can tell you. Okay, so hats off to you, you are still here, and I believe that you will learn a lot. Okay, so can you please plot and write at least the dual of this? What should I write? Dual. Because it's a maximization type problem, I'm going to write minimization z dash equals to, okay, it cannot be z, okay, maybe I wrote z over here. I'm going back. Okay, I have not written z, okay, fine, so this is good. Yes, I have not mentioned z, so here I am mentioning z prime equals to 6x plus 6y. These I have taken from here, right hand side, and subjected to 3x plus 2y. Because it's a less than equal to sign, I'm going to write greater than equal to 4. I get it from here, right? Then 2x plus 3y is greater than equal to 6. This right hand side is derived from here, right? And x comma y is greater than equal to 0. Okay, this is how it goes. Yes? Now can you please try to find the solution of this? Can you please try to plot them? All right. So 6x plus 6y, minimization type, 3x plus 2y greater than equal to 4, 2x plus 3y greater than equal to 6. We are good here. Let's try to plot them. Okay. So firstly, let's see how much this comes. Let's say here we have 3, 3, y equals to 2, 0, 2. So it's greater than equal to side. So this is what it is. Greater than equal to, because the coefficient of y is positive, so it's the upside, all right. And x equals to 3, 0. And y equals to 2. So I'm going to join like this. And this also says that it's greater than side. So what's the common in this? This is the common thing, right? Yes? How many corner points are there? Okay, Neha says D. D is unique solution. Okay. Okay, good. So how many corner points are there? How many corner points are there? Again, I'm repeating, how many corner points are there? The sociopath says 3. Okay, this is the region. One corner point is over here, right? The other one is over here. I can see just 2. Right? Hello? I can just see 2. Do you agree? Yeah. Mohammed, do you agree that it has 2 corner points? Yes, sociopath, you also agree. So, do you also agree that this is the region that you are getting? Did I do any errors? Because I might also do errors. I am a human being, right? Okay. Are you getting the same feasible region? Neha says yes. Good. Okay, fine. Now, find z dash at these 2 points. Firstly, 0, 2. What is that? 0, 2. That's 12. Z dash at 3, 0 equals to 18. And because it's a minimization type problem, what's the answer? $12. Yes. So what is the type of solution we are getting from this? What is that? Neha, you are right. It has a unique solution because we are just getting one solution, not infinitely many solutions, as Mohammed Yusuf was saying. Alright, it's fine, Mohammed. At least you are there, and I really appreciate you being here because you value time, okay? And once you start valuing time, time also starts valuing you. It's really very important to use time because time is the greatest resource that we have. Do you agree? Unique? Yes? Okay, fine. Unique solution. Okay. Is that good? Fine. Now you tell me the answer of this. Please come up. You have take 5 minutes for this and please come up with a solution. All right? Right, please come up with a solution. And if you remember, we had already done this. This was giving us unique solution. So that's why Devansh, I want you to understand that let's not generalize it. Okay, it depends on the problem and it might not have a relationship all the time. Because as we saw, the infinitely many solutions given by the primal, if you convert that primal into dual, dual is giving a unique solution, right? Okay, so can you please try this? Come on, quickly. Let's do it together. Okay, so I'm going to write dual. What do I write? Minimize z dash equals to 10x plus 8y. I take it from the right hand side. Yes, 10x plus 8y subjected to 3. Okay, let's not take x and y because x and y are already there. Let's take something else. Let's take x1 and x2. Subjected to 3x1, 3 I have taken from here. Now I'll take 4 from there plus 4x2. Because it's a less than equal to type sign, I'm going to write greater than equal to, and 3 I'm going to take it from here. 3. Yes? Yes? And this is 7x1 plus 6x2 is greater than equal to 7. And x1 comma x2 is greater than equal to 0. Right? 3x1 plus 4x2 greater than equal to 3. 7x1 plus 6x2 is greater than equal to 7. Please tell me the type of solution. Alright? Okay, you say infinitely many solutions. YouTube Live, Sociopath. Okay, Sarath says 3. What is 3? The option 3, Sarath? Are you talking about option 3? And okay, Yusuf says unique. Okay, Neha says exactly one optimal solution. Okay, fine. Good, good. Mohan says exactly 2 optimal solutions. 2. 2 is a bit weird, I guess. Yeah. But yes, you might have 2 optimal solutions as well, yes. Why not? But when you have 2 optimal solutions, you say that you have infinitely many options, right? Right, so that option is actually wrong to me, seems wrong to me. Okay, so let's try to plot this. This is x1, this is x2. Okay, now x1, 1, 0, x2 is going to be 175, right? And x, when I join this is greater than equal to, so it says go up. Alright, because this is greater than equal to, and x2's coefficient is positive over here. Okay, nice. Now this one, 1, 0 is this point, and x2 is 7/6. What that would be? 1.16. Okay, so let's take it over here. 0.116. Okay. So this is how it's coming up, and it also says go up. Right. Okay. So this is the feasible region that we are getting. Yes. Now how many corner points? How many corner points? Come on. Neha has already calculated the answer. Okay. How many corner points? YouTube Live, D, infinitely many solutions. You say that the value of optimal objective function at these 2 points is same. Is that it? That's when we get multiple optimal solutions, right? Okay. So 2 corner points over here. Number 1 and number 2. So just try to find out z dash at 0, 1.16 equals to 10 into 0 plus 8 into 1.16 equals to, please calculate this, and z dash at 1, 0 equals to 10 into 1 plus 8 into 0. This is 10, this is how much? It should be 9.28. Right, so we are just getting one solution over here. That is 9.28. Yes? Yes? Coincidence of 2 lines have infinitely many solutions. I have already told you, Mohammed, when you would have gotten same value of z dash in these 2 points, then you would have said that infinitely many solutions, right? Here the values are different. Here you are getting 9.28, here you are getting 10, and it's a minimization type problem. So yes, that's exactly one optimal solution. Right? No, it's not infinite. YouTube Live, if you have not watched the previous videos, I suggest you go back and watch them, because I have discussed when do we get infinitely many solutions, okay? So you might find it there. Alright? Yes, so Mohan also said that it's B. It is B actually. Okay, fine. Any questions in this? Any questions? Okay, so please go back to my previous videos and try to understand. And let me tell you that understanding is more important than doing questions over here, okay, or anywhere. And if you understand, and even if you don't do many questions, I think you are going to be through. And this is how it is. This is what I can tell you from my own experience. When you understand the basics, it becomes really easy for you guys, okay? And because you have already started it on time, okay? So it's really great that you guys have already started in time, because time is variable, as I keep on repeating, okay? Degeneracy, yes, Ankit will understand it when we do, when we proceed forward. Degeneracy, what is the meaning of degeneracy and why does it come up, all right? And I hope I had a good thought-provoking session to you guys, and I hope that we'll come back soon with another value-adding videos to you. And till then, I say to you, be happy, always do good, always be peaceful from your heart, and I say that Happy New Year, because tomorrow we are not going to meet. So right now I'm saying Happy New Year. May this New Year bring you lots of happiness, lots of joy, success, money, whatever you want to desire, and be blessed by the divine, all of you. All right, so let's see. Ankit will take a problem, degeneracy. We'll try to understand it when we do simplex and bigger methods. All right, until then, I say be awesome. Okay, thank you very much.